Today we shall go for rank of a matrix. Every matrix will be having a rank. Depends on any order. Not necessarily to be a square matrix. For any type of matrix there is a rank. So a matrix will have always a rank. Then rank of a matrix A written as row of A is less than or equal to minimum of its order m cross n. So if a matrix is of order m cross n, the minimum number either m or n will be equal to or less than or equal to rank of that matrix. So rank of A is defined by less than or equal to minimum of its order. So for a matrix, the rank is determined by its order. Now, suppose if I have to find out the matrix order, means we can have two types to find the matrix order, the rank of a matrix. In that one, first type is determinant method. How to find the rank using a determinant method? Suppose if there is a matrix is given, if it is of order m cross n, that is if it is a rectangular matrix, then by taking a cofactor matrix, then it may become a square matrix. Or if it is given as a square matrix, we can find the determinant strategy. So make a matrix to be a square matrix by suppressing a row and column to get a square matrix. If it is a rectangular matrix, that is of different order. Otherwise, we can take that matrix as it is and find the determinant of this matrix. If delta of any matrix, that is if determinant is non-zero in any order, in an order n cross n, then rank of A equal to n. So, if the determinant where it is not vanishing, in an order at which it is not vanishing, then that order gives the rank of the matrix. Suppose if I take a 2 cross 2 matrix, if 2 cross 2 matrix A equal to, A is of order 2 cross 2, then if determinant of A and determinant of A is non-zero, then rank of A is 2. Suppose if determinant of A equal to, if determinant of A is 0 at A of order 2 cross 2, A of order 2 cross 2, then rank of A will be less than or equal to 2, maybe 1. If it is less than 2 means definitely it will become 1. That is rank of A equal to 1. So this is called finding the order of a matrix using determinant method. Take a matrix of any order. If it is a square matrix, you can take that order straightly. Or if it is a rectangular matrix, take the cofactor matrix as a square matrix. Find out the determinant of that matrix. If the determinant is non-vanishing, that is if the determinant is not becoming 0, then that order determines the rank of the matrix. Suppose if it is becoming 0, then go for the cofactor matrix that will be less than the order of the given matrix, then that order will determine the rank of the matrix. We are understanding while doing problem. This is one method. Then method 2. Type 2 is row reduction form or row echelon form, and we say in our book as row reduction method. Row reduction method or row echelon form. This method is taking a matrix, whether it is a square matrix or non-square matrix, and bringing the number of zeros inside a matrix by reducing the rows, making the rows to become 0, and the method we used to say as elementary transformation method. And if we are able to make many number of zeros, many number of rows as 0, then the remaining rows will determine the rank of the matrix. While doing problem, we can understand this. So let me go for return method first and then row reduction method next. Exercise 1.2. First problem. Find the rank of the following. By minor method, that is determinant method. First one, A equal to 2 minus 4 minus 1, 2. So we shall find, this is by determinant method, minor method means determinant method. So find determinant of A. Is it not 4 minus 4 equal to 0? That is, a 2 cross 2 matrix is becoming 0. Therefore, rank of A will be less than or equal to 2. When I reduce here, or if I take the cofactor, then the cofactor will become a 1 cross 1 matrix, isn't it? Therefore, rank, that will be always non-zero. So, rank of A equal to 1. So, the 2 by 2 matrix is given and that is becoming 0 when I find the determinant. Therefore, rank is not 2. Then less than 2 must be only 1 because cofactor matrix for 2 cross 2 will be only 1, which is non-zero. There exists at least one number which is non-zero. Therefore, rank of A is 1. Problem number 2. Let me take it as B. Minus 1, 3, 4 minus 7, 3 minus 4. So, this is not a square matrix, therefore, it is a rectangular matrix. So, let me consider a cofactor matrix. Let B equal to, suppose if I take minus 1, 3, 4 minus 7, B dash we shall say, then modulus of B dash is 7 minus 12. Which is minus 5, non-zero. Therefore, your 2 cross 2 minor is becoming non-zero. Therefore, rank of B equal to 2. Because at 2 cross 2 minor only, I did not get 0. Therefore, rank of B is 2. Third one. Suppose if I take C. 1 minus 2 minus 1, 0. 3 minus 6 minus 3, 1. So again, this is 2 rows, 4 columns. So I can go for a minor. Let 2 cross 2 minor of C. C dash equal to, shall I take the first one? 1 minus 2, 3 minus 6. Then it is minus 6 plus 6, it becomes 0. So let me go for another, this implies. So I cannot conclude, let me go for another minor. Suppose if I take this one, minus 2, minus 1, minus 6, minus 3. Then determinant of C double dash is 6, minus 6, again it becomes 0. So let me go for some other C1, that is minus 1, 0, minus 3, 1. So when I find C1 determinant, it is minus 1, minus 0, minus 1. There exists a non-zero in 2 cross 2 minor. So if you are able to find at least one minor matrix in which the determinant is not equal to 0, that determines the rank of the matrix. Here it is non-zero at 2 cross 2, therefore rank of C is, equal to 2. This is determinant method. Now we shall go for problem number 4 and our let A equal to 1 minus 2, 3, 2, 4 minus 6, 5, 1 minus 1. Now We shall find, since it is a square matrix, let me find the determinant straightly. So it is 1 into 4 minus 6, 1 minus 1, plus 2 into, omit the row and column, 2 minus 6, 5 minus 1, plus 3 into 2, 4, 5, 1. It is 1 into minus 4 plus 6, plus 2 into minus 2, minus 30, so plus 30, plus 3 into 2 minus 20. It is 6 minus 4, 2, 2 ones are 2, 30 minus 2, 28, 28 twos are 56. It is minus 18, minus 18 into 3 is minus 54. So 58 minus 54 is 4, not equal to 0. So a 3 cross 3 matrix is non-zero, therefore rank of A equal to 3. Lower, since it is a 3 cross 3 matrix, the determinant of 3 cross 3 matrix that became non-zero, therefore rank of A is 3. That is your fourth problem. Now we shall go for next one. Suppose if it is not a square matrix. A equal to 0, 1, 2, 1, 0, 2, 4, 3, 8, 1, 0, 2. The order of the matrix is 3 rows, 4 columns. So if I take a minor, the minor will be a 3, 5, omit any row, then it will be a minor. So consider a 3 cross 3 minor. Let A dash equal to, if I take 0, 1, 2, 0, 2, 4, 8, 1, 0, we shall find this determinant of A dash. It is 0 into something, minus 1 into 0, minus 32, straightly, plus 2 into 0, minus 16. This is 0, plus 32, 2 16s are minus 32, it becomes 0. Therefore, it fails in this first row. So let me go for another determinant. Shall I take A dash as, let A1 equal to 0, 0, 8, 1, 2, 1. Instead of this column, shall I take 1, 3, 2? Now we shall find determinant of A dash, A1. It is 0 into something, minus 1 into 0, minus 24, plus 1 into 0, minus 16. This is 0, plus 24, minus 16. 14 minus 6, 8. 8, isn't it? So this is not equal to 0. So the determinant is not becoming 0 in the order of 3 plus 3. Therefore, rank of A equal to 3. So this is something a tedious method, because suppose if I take all the 3 cross 3 minor, I can have 4 3 cross 3 minus, isn't it? Or if all the 4 3 cross 3 minus is becoming 0, then I have to go for 2 cross 2 minor. If I go for 2 cross 2, I will be getting at least 16 2 cross 2, and if all are becoming 0, then I have to go for single one, that is 1 cross 1. So it will be a tedious one. So the determinant method is always not encourageable. So I have to go for some other method. That method is called row echelon form or row reduction method. So we shall do problems in the row reduction method. And it is always advisable, whenever they give a 2 cross 2 matrix, you go by determinant method. If it is more than 2 cross 3, if it is 3 cross 3 and more, better go for row echelon form. That is second problem. Find the rank of the following by row reduction method. First one, A equal to 1, 1, 1, 3, 2 minus 1, 3, 4, 5 minus 1, 7, 11. Now, let me go for an equivalent matrix. So, we is write equivalent. The first row we are not at all disturbing. So, we should keep the first row as it is. Second row, below to this 1, the first two elements must become 0. This 2 must become 0 and then this 5 also must become 0. For that I can do any elementary transformation by multiplying and subtracting or doing division, addition, subtraction, whatever it is. Suppose if I multiply the first row by 2, then I get 2. When I subtract this 2, this will become 0, isn't it? Then this 2 will become 0. And this kind of transformation is called elementary transformation. So what I am doing, I am keeping R1 as it is and I am writing R2 as R2 minus 2R1. That means I am multiplying all the number of row of elements as by multiplying by 2. Then what is R2? 2 minus 1, 3, 4. This is R2. When I multiply each number by 2, it is 2, 2, 2, 3 2s are 6. And we are subtracting. So minus, 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 minus. So it becomes 0. Minus 3 plus 1. 4 minus 6 is minus 2. This is my new second row. That is 0, minus 3, 1, minus 2. Now, I need this pi also to be 0. Let me operate with the same R1. That is, when I multiply this one by pi, pi minus pi equal to 0. But I cannot do for a single element. I must do for a complete row. That is, R3 is written as R3 minus 3R1. Better you write in the left column. What is R3? 5 minus 1, 7, 11. Now multiply the first row by 5. 5, 5, 5, 15. Change the sign. Minus, 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 minus. It is 0. Minus 6, 2. Minus 4. So it is 0, minus 6, 2, minus 4. This is making first row as it is, second row first element as 0, third row first element as 0. Now what we have to do is, suppose if I have 1 0 in the second row, then there must be at least one more 0 in the third row. That is, I am having 1, 0, 0. Here 1 0 is there, therefore I must have at least one more 0 in the third row. That is, this minus 6 must become 0. But I cannot do operation with R1 now because I need this 0 also. So better we should go for operation or transformations between row 2 and row 3. That is, A is written as 1, 1, 1, 3. Row 2 no change. 0, minus 3, 1, minus 2. Since this minus 6 must become 0, I can do only with the R2. If I multiply this one by 2, this will become minus 6. When I subtract, the sign will change. Therefore, that will become 0. So what I am doing? R3 is written as R3 minus 2 R2. So what is that? R3 is written as 0, minus 6, 2, minus 4. Multiply R2 with 2, 0, minus 6, 2, minus 4. When I subtract, sign will change. Minus, plus. So it becomes 0, 0, 2 minus 2, 0, minus 4 plus 4 is also becoming 0. So all the elements are 0. So there is 1, 1. Before that, below to that term 0. Below to that at least one more 0. If this is called row reduction method or row echelon form. When you obtain this form, you don't need to go for further reduction. You can stop here itself. Now see, in how many of the rows having non-zero elements. In the first row, all the numbers are existing other than 0. Therefore, in first row, all the numbers are non-zero. And in the second row, minus 3, 1, minus 2, these 3 are non-zero. Therefore, in second row also there are non-zero numbers. So in first row there are non-zero numbers, in second row there are non-zero numbers, whereas in third row all have become 0. So only in 2 rows I am having non-zero numbers. Therefore, rank of A is equal to 2. Because there are only two rows having non-zero, therefore rank of A is 2. This is called row reduction form. So that only I did not define in the definition. I just want to do this one in the problem so that you can understand well. Keep the first row as it is. If it is in 1, it is well and good. Then make these two first numbers of row 2 and row 3 to become 0. Just find out how many zeros are there in the second row. If there is only one zero, then I must have at least one more zero at least in the third row. So I got almost everything is 0. So this is of this format I am getting. That is 1, 1. Below to that, a triangle 0. An upper triangle matrix like. Therefore, this is the form called echelon form or row reduction form. So no need of go for further reduction. You can stop here itself after getting this formation. Then number of non-zero and number of rows having non-zero will determine the rank of the matrix. Therefore, rank of A is 2. That's all. Now we shall do the remaining problems. Similarly, second problem. A equal to 1, 2 minus 1, 3 minus 1, 2, 1 minus 2, 3, 1 minus 1, 1. So first row, first element is 1. So I am not at all doing anything with the first row. Now this 3, 1, 1, everything must become 0. All the first entries must become 0. So what I am doing, R2 is written as, if I multiply with this 3 minus 3 becomes 0, isn't it? So R2 minus 3 R1. I cannot do for only one element, I must do for all elements. Similarly, now this is 1 only, so 1 minus 1 becomes 0. So straightly, R3 is also written as R3 minus R1. Similarly, R4 can be written as R4 minus R1. We shall do all these three together. Better write it in the rough column, find out and then fill up here. R2 is 3 minus 1, 2. Multiply R1 by 3, 3. 3 2s are 6, minus 3. When I make minus 9 only, it becomes 0, so subtract. So it is 0, minus 7, minus 1. This is second row. R3 is 1 minus 2, 3. R1 is 1, 2, minus 1. Subtract, this will become 0, minus 4, 4. This is third row. Then R4 minus R1, 1 minus 1, 1. 1, 2, minus 1. I have to change the sign. So 0, minus 3, 2. Therefore, second row is 0, minus 7, minus 1. 0, minus 4, 4. 0, minus 3, 2. So all the first entries have become 0. Now, since there is 1 0 in the second row, there must be at least one more 0 in the third row. Then automatically this also must become 0, isn't it? So, let me go for further transformations. A is equivalent to 1, 2, minus 1. There is no change in the first row. Now the second row also, there are more. You don't want any more changes here. Now this minus 4 must become 0. But I have to do only with the R2 because this 0 must be maintained. So shall I multiply this one by 7 so that this will become minus 28 and this one by 4 that will become minus. So what I am doing, I am writing R3 as 7R3 so that this will become minus 28. Minus 4R2 that will become minus 28 and if I change the sign that will become 0. So shall we do this one first? So I am multiplying R3 by 7. 0 minus 28 plus 28. Now multiply R2 with 4. 0 minus 28 minus 4. Change the sign because we are subtracting. So this becomes 0, 0, 32. 0, 0, 32. Similarly, shall I multiply this one by 7, becomes 21 and this one by 3, that will become 21. So R4 is written as same 7R4 comes minus 21, and then minus 3R2. 3 sevens are 21. Shall we write here? So 7R4, 0 R4 minus 21, 40. Now 3R2, multiply R2 by 3, 0 minus 21 minus 3. Minus means I have to change the sign. 0, 0, 17. So it is 0, 0, 17. Now can you understand? 1, 1. Now 2 0. Then at least there must be one more 0 in the fourth row. That is, this 17 must become 0. But I can do only with R2 and R3 and R4. So again A is equivalent to 1, 2 minus 1, 0 minus 7 minus 1, 0, 0, 32. Therefore, only I can do, therefore R4 is written as, just multiply this one by 32, that one by 17, that's all. 32 R4 minus 17 R3. So just find out 32 into 17. 2 17s are 2 sevens are 40, remember 2 ones are 2, 34. 3 17s are 51. 4, 4, 5. So it is 0, 0. Sorry. Yeah. 0, 0. 32 into 17 is 544. 0, 0. 17 into 32 is also 544. Minus 0, 0, 0. So it is 0, 0, 0. Now see, in how many of the rows we have 0, non-zero. First row there is non-zero. Second row also containing non-zero numbers. In third row also 32 is non-zero. So 3 rows I am having non-zeros. Therefore, rank of A is equal to 3. This is how we can find the rank of the matrix. This is a better method when it is compared with the determinant method. Now we shall go for problem number 3. A equal to 3 minus 8, 5, 2. 2 minus 5, 1, 4. Minus 1, 2, 3 minus 2. A is equal to, the previous two problems we get the first row, first element to be 1. Here we don't have. If it is not there, no need to keep anything. You can just keep it as 3 minus 8, 5, 2. This row 2, this number and this number must become 0, isn't it? So shall I write R2 as, if I multiply this one by 3, it will become 6. If I multiply this one by 2, that will become 6. So R2 is written as 3R2 will become 6 minus 2R1, that will become 6. So multiply R2 by 3, 3 2s are 6, 3 5s are minus 15, 3 3 4s are 12. Multiply first row by 2, 6 minus 16, 5 2s are 10, 2 2s are 4. Change the sign, because I need this one becomes 0, minus, plus, minus, minus, 0. 16 minus 15, 1, minus 7, 12 minus 4, 8. This is your new R2, 0, 1, minus 7, 8. Now R3. Shall I multiply this one by 3 and add? That is 3R3 plus R1 straightly, plus minus 3 plus 3 will become 0. So 3R3 is minus 3, 6. 3 3s are 9, 9 to 2 3s are minus 6. Now at the first row as it is 3 minus 8, 5, 2. When you add 0, minus 2, 14, minus 4. So it is 0, minus 2, 14, 4. You don't need to change the sign because we are adding. Now, First row we are having the number, second row 1 0 is there, therefore third row there must be one, at least one more 0, that means this minus 2 must become 0. Shall I multiply this one by 2 and add? What is that? What we are doing? I am keeping R3 as R3 plus 2R2. I multiply this one by 2, it will become plus 2. When I add minus 2 plus 2, it will become 0. So it is 3 minus 8, 5, 2. Second row as it is. Now coming to third row. R3 is written as it is. 0 minus 2, 14, 4. Now multiply R2 with 2, 2. 0, 2. Minus 14. 8 2s are 16. So when I add, this will become 0. This will become 20. Therefore, this is 0, 0, 0, 20. Now see, we arrive at this echelon form. First row there are non-zero numbers, second row there are non-zero numbers, in third row also one number is non-zero. Therefore, rank of A is 3. In all the 3 rows I am having non-zero numbers, therefore rank of this matrix is 3. So this is called row reduction form or